Hello, everyone. I'm Aurore A Perrault, and I worked as postdoctoral fellow at Concordia University in Montreal. I'm very happy to present our sleep behavior profiling project. A little bit of history. So this project was initially conducted in Thomas Yeo lab in Singapore by Nicole Quek and Valeria Kebetz. And Valeria flew in 2020 in Montreal and invited me as well as some collaborators to work with her during the lockdown. And this is the study that I'm going to present today. I'm more in the sleep side of this project, but I'm very happy to present to OHBM today. So if I tell you that sleep is important for daytime functioning, health, well-being, cognition, you would say that you already know that. And indeed, many studies show that sleep affects all dimensions of our life, but also that sleep is permeable to external factors, suggesting that there is a bidirectional relationship between sleep and behavior. The thing is, you know most of that because sleep and behavior are mostly studied in a single association manner, with either it's going to be sleep with depression or sleep and obesity, or even it's going to be just one dimension of sleep that will be studied, such as sleep duration, sleep satisfaction, sleep latency. What we propose here is to use a more multidimensional and data-driven approach to extract sleep behavior profile that will be defined by a distinct self-reported sleep pattern and clinical, cognitive, but also lifestyle factor in a healthy adult. So how can we do that? Well, thanks to the Human Connectome Project dataset that comprise MRI data, but also a large range of self-reported questionnaires on lifestyle, mental health, physical health, but also personality, affect, as well as objective measure of cognition and physical health. Our main assessment of sleep will be extracted from the self-reported questionnaire called the Pittsburgh Sleep Quality Index that actually assess a lot of the dimension of sleep, duration, satisfaction, etc. From the 1,200 healthy young adults from the HCP dataset, we were able to use 770 adults with complete data. So, like I said, we use a data-driven approach. And for that, we deployed an unsupervised machine learning technique that is called Canonical Correlation Analysis, or CCA, which seeks the maximal correlation between combination of variables in two matrices. So these two matrices that we load are obviously sleep first. So it is linked to the PSQI, so which has 19 questions that can be computed into 7 composite variables that will assess specific dimension of sleep, such as sleep duration, satisfaction, disturbance, but also the use of sleep med on the whole and how they think sleep can affect the daytime functioning. The second matrix is a behavior one, where we have 118 variables that is linked to questionnaires on demographics, physical health, mental health, affect, personality, substance use, but also objective measure of cognition, such as memory task, emotional processing task, etc. So we deploy CCA on both these matrices, and it maximally correlates these two matrices and extract latent components that we call sleep behavior profile. And they are characterized by high loadings of specific variable in both matrices, as well as each profile has score in every individual. So basically every individual has a score on each of the profile, and it's present at varying degrees. So it's not a subtype, it's really among all of us, but we have more or less varying degree of this profile. And with such an incredible data set as the HCP is, you have access to also MRI data, so which allow the investigation on whether such profiles could be characterized by specific pattern of brain network organization. And that's why we use the resting state functional connectivity in order to basically post hoc, we did an association between individual score on this profile and individual raw brain resting state functional connectivity. And that gave us a resting state functional connectivity pattern for each of the profile. So we find 5 significant profiles that link sleep and behavior. Now, for a reason of time, and because these two did not reveal a strong functional connectivity profile, we thought that for this crowd, maybe I'm just going to present 3 today, but please come to our poster if you want to know them all. So the first profile present a general worsening in all dimensions of sleep. So they basically score high in all the dimensions of sleep, as you can see here, which high mean worsening. And they were associated with high loading in psychiatric issue in green, such as depression, anxiety, internalizing, but also with negative effect in pale pink, such as anger, stress. Thus, we think that this profile reflects general psychopathology or P factor. Another profile, this one is have a more strong loading in sleep duration, which here mean not enough sleep. And that was associated with a lot of cognition factor, including slow reaction time, reduced accuracy in working memory, emotion processing, social cognition. So this profile seems to reflect a link between sleep duration and cognitive performance. The last profile emphasizes more on high loading in sleep disturbance, which will complain of multiple awakening, pain, breathing issue during sleep, etc. And is associated with some poor cognitive performance, but mostly associated with psychiatric issue, but also substance abuse. So this one seems to reflect more sleep quality with cognition and mental health. So how about the functional connectivity pattern? So the first one, the P factor, do not show such a strong connectivity profile. However, we do see some increase on functional connectivity between the subcortical region and the somatomotor network, and computational of modularity index, which is basically a ratio of integration by segregation within cortex, reveal more segregation in visual and limbic network. Otherwise, but if you compare with the sleep duration one, we see a much more stronger connectivity profile with an imbalance between integration and segregation that differ across the cortex. Specifically, we see a high segregation on the somatomotor network. Additionally, the default mode network appear to be less connected within and become more integrated with the attentional network. Another way to look at it is by computing the participation coefficients that can show how much a region is connected to outside its own network. And we see the somatomotor show less between functional connectivity. Interestingly, this is a profile that has been previously shown in sleep-deprived individuals with link to cognitive impairment, which is interesting as here they are healthy adults who are not in the controlled sleep deprivation protocol, but still show similar pattern. Finally, we have the sleep quality one that exhibit a more reverse pattern where individuals that score high on this profile show a lower functional connectivity within network. And while the integration segregation pattern was less clear, we found that compared to the other profile, LC5 show a general reduced within network in all network. Now, I would like to talk more about it, but because of time constraint, in summary, we use a multidimensional approach to extract distinct patterns of self-reported sleep linked to different specific health, cognition, and substance use factor in healthy adults. We also found that some of these profiles actually display specific functional connective signature at resting states. I would like to finish on that quote from a friend: sleep is an opportunistic window to the brain. And indeed, I think that what our project brings to the table is the multidimensionality of sleep and how central it is for our functioning, as a daytime functioning, but also health. And we should not only in research, but also in clinics, put more emphasis on self-reported sleep in the clinical anamnese, but also use sleep to have a deeper understanding of depression, substance use, cognitive decline, etc. I would like to thank you for your attention and acknowledge again my two co-authors, Valeria Kibetz and Nicole Kwok. Thank you.